Okay, this problem right here is similar to the previous problem. You can look and see the like factor of x minus 3. This guy leaves an x squared, while this one leaves a plus 12 when you pull out those like factors. Like factor here is the single x that they all have in common, leaves you with an x squared plus x plus 1. This brings up the important point that even though we divided out the entire x, you still have to have a 1 there. You need to be able to distribute back and get what you had. So x times x squared is x cubed, x times x is x squared, x times 1 is x. And these guys all have a 3 in common. No variables in common with all 3 of them. That will leave you with a 5a plus 4b plus 2c. These guys have a y in common, leaving you with an x squared plus 2 when you factor that out or divide that out. And then you've got a page that is practiced. I'll work some of those tonight. Up next we have factoring by grouping. So you always look for a GCF first. Sometimes there isn't one, okay? There's not a GCF. You've looked for it. You've even pulled it out maybe. And what you have left behind is still 4 terms. You're going to try factoring by grouping. Okay, it doesn't work on every single 4-term expression, but the way that this works is you'll group the first 2 together, then the last 2. Then you're still going to factor out a GCF from each of these binomials and then factor out the common binomial, okay? So pairing up the first 2 as well as the second 2. These guys have an x squared in common, leaving behind an x plus 7. Super important to bring this sign down to the middle here. The 2x plus 14 have a 2 in common. When you divide that 2 out, you have an x plus 7 left behind. So factor by grouping works. These left behind binomials will match each other, and that's the like factor that we're going to write first. And then these guys create your other factors, so x squared plus 2. Pair up the first 2 and the second 2, and I just always leave that middle sign just kind of hanging out because he will carry over into my factoring here. GCF of 3x squared plus xy is just a single x, leaving behind 3x plus y. Minus sign comes down, okay? You've got your 12x minus 4y, so they are going to have a 4 in common. Now, it's essentially operating as a negative 4, so if you have a negative 12x, you divide out a negative 4, you're going to get a positive 3x. Negative 4 times 3x is negative 12x. If you had a negative 4y and you divided out a negative 4, a negative divided by negative is a positive. We got our 4 out of there, so we've just got a y left. They match. That will be one of our factors, while the x minus 4 will be the second one. Pair up the first 2, and you do want to look for GCFs initially. Like, is there anything we can get out of all 4 of them? Not so much. Okay, you can get some 3s out of those guys, but not him. You can also get some p's out of these guys, but not the 5. So nothing we can factor out of all 4. So pair up first 2, pair up last 2, factor out the GCF of 3p squared. 9 divided by 3 is 3. You factored out 2 of those 3p's, so you've got a single p left, and this is actually going to leave behind just a 1. Bring your little plus sign here. The 15p and the 5 have a 5 we can divide out, leaving behind a 3p plus 1. Again, they match here. That will be one of our factors, while the 3p squared plus 5 will be the other. Glancing across here, I actually see a 6 that can come out of everything. Let me see if there's any variables. He's got an a and a w, an a and a k, no a's here. Nothing. It doesn't look like they can come out of everything. So leaves behind an a, w minus, I got my 6 out, so 6ak plus b squared w minus, I got 6 out of here. Well, actually, yes. I'm doing so far with all the 6s. So I got the 6 out of the 36, so 6b squared k. So still 4 terms. Let me go ahead and change these to brackets, because with the 4 terms that are left behind, I'm still going to try to factor by grouping, okay? So parentheses around each pair. Okay, I know it gets a little confusing. So the 6 here is just going to kind of hang out until we can square away kind of what we're working with in here, okay? So the AW and the 6AK just have an A in common, okay? Leaving behind a W minus 6K. bring your plus sign down. So this 6 is just hanging out. Now we're like factoring by grouping right here, okay? B squared W, and then you got your 6B squared. Okay, so they just have a B squared in common. Leave behind a W minus the 6 that we didn't get to pull out. We pulled out the B squared, but we didn't get to pull out the K. So they match like we've been needing them to do in factor by grouping. So W minus 6K is one of your factors, and the A plus B squared is the other, okay? And 6 is still here, okay? He was initially factored out as our GCF of the original. No GCF in all 4. Pair them up, get out my 5x squared that those guys have, leave behind a 3x plus 1. Really nothing to pull out, so we're just going to pull out a 1, leave behind a 3x plus 1. They match here. These guys will create one of your factors, and then the 5x squared plus 1 will create the other. Glancing across here, I know 12's got like a 4 and a 3 and a 2 and a 6. 20's got a 4 as well. 84 is going to divide by 4. 140, if you divide him by 4, it should work evenly, and you guys will have calculators, but it definitely does work evenly. Okay, so it looks like I can definitely get a 4 out of everybody. That's about it. So it's probably going to look like the one above here, okay? I don't think I'm going to have enough time on this video to finish it up, so I'm going to pause this video, upload it, and then get another one going.